Today we are looking at target 1.4, and 1.4 is I can evaluate function notation, I can combine functions algebraically, and I can compose functions. So we're going to be looking at all three of these I can statements today. And the first thing we're going to look at is remembering that f of x is said f of x. So on the f with x in parentheses, again, is f of x. It's not like f times x or whatever. And again, remember that f is your name of the function. So this is function f, and x is what you're like inputting. And we'll see some examples of how we can like switch that up. So let's look at example 1. Okay, so we're looking at what we call function notation. Okay, so let f of x equal to x minus 3. So the first thing we're going to find is f of 2. Okay, and if you notice, oh, I don't think I have my touch on. Hold on. There we go. That should work better. This 2 is in the place x was. So what I'm doing is I'm taking this function, 2x minus 3, and I'm just going to replace every instance of x with a 2. And then I come to an x, so I'm going to replace it with 2 minus 3. So again, I took this x and replaced it with what's in our parentheses here. Okay. So then 2 times 2 is 4. And 4 minus 3 is 1. So f of 2 is 1. And what that tells us is the point 2, 1 is in this graph. Okay, so that would be your x and your y value of your graph. Same thing here. I have -7. So again, I'm just going to do the same thing where I replace every instance of x with -7. So I get 2 7 minus 3. 2 times -7 is -14 minus 3, and -14 minus 3 is -17. So now c is a little bit different. It's not a number. It's this x plus 5, but it's in the same place as this 2 and this -7. So even though it's its own expression, it's going to act that same exact way. I'm just going to replace x now with x plus 5. And then we have, this will equal, I start with my 2, and then instead of my x, I'm going to have x plus 5. Minus 3. I'm going to distribute my 2. So I have 2 times x is 2x. 2 times 5 is 10. Combining my like terms, 10 minus 3 is 7, so I get 2x plus 7. So if I have an expression that I'm substituting in, a lot of times my answer is an expression at the end. Okay, it still has like a variable in it. Where if I have a number, my answer is usually a number at the end. Let's look at another example really quick. Example 2. Let h of t equal t squared minus 3t plus 5. So now this is a little bit different, right? We're used to the f of x, but this is just as valid. This is h of t. The name of my function is h, and my variable is t. That's my input. It works exactly the same way. So I'm going to have, right, whatever is in the here, right, be replaced by whatever in there. So every time I have a t, which now there's a t in 2 different places, I'm going to replace it with this -4. And this squared is on the outside. Minus 3 times -4, and then plus 5. Well, -4 squared is the same as -4 times -4. 16. -3 times -4 is positive 12, so I'm going to add 12 plus 5. And then I'm just going to add these three numbers together. 16 plus 12 is 28, plus 5 is 33. Okay, let's look at part B, h of 3x. Again, there's an x in there, but it's still the same idea. I'm going to replace that x, or that t, with 3x. So again, it starts with a t, so I'm going to have that 3x squared minus 3, and then we have a t, so in my parentheses I'm going to put 3x, and then plus 5. So 3x squared is the same as squaring these things individually. You can think of it as 3 squared and x squared. And then 3 times 3x is 9x. We do not distribute. There is no plus or minus sign within that 3x, so there is no distribution. And then 3 squared is 9x squared. Minus 9x is 5. Okay. That is it for function notation. Let's look at our next thing. So our next thing is algebraically combining functions. So we can like add, subtract, multiply, divide functions. And we have this like special notation. So if it's f plus g of x, all you're really doing is f of x plus g of x. You're adding the two of them. F minus g of x is the same as just subtracting the two functions. F g of x is the same as multiplying. And then f over g of x is the same as dividing. Okay? The only special thing about your quotient rule is, remember, we can't divide by 0, so we have to make sure that g of x is not equal to 0. So let's look at an example. We're going to let f of x equal x squared plus 3. And g of x equal x minus 1. So those are our two functions. So the first thing I want to do is find f plus g of x. Not let me click on things. So f plus g of x, remember, that is the same It's just so slow. That's what it is. Hold on. Okay, f plus g of x, let's see if this is better. It's the same as it's a little bit better. F of x plus g of x. So I'm going to take this f of x and I'm going to put what f of x is. Right, so that x squared plus 3. And any time I substitute something in, I want it in parentheses. So I have x squared plus 3 plus, and And our g of x is x minus 1. Okay. When I'm just adding, I can just combine like terms, and my 3 and my minus 1 are my only like terms. Right? So I really have x squared plus x, and 3 minus 1 is plus 2. So we get f plus g of x is the function x squared plus x plus 2. Okay, part B, f minus g of x. Remember, f minus g of x is the same as f of x minus g of x. So again, I'm going to take, I want to make sure I substitute it in with parentheses, so I have x squared plus 3 minus our x minus 1. Now this is where we have to be careful, and the parentheses really matter, because with subtraction, I'm doing the opposite of both of these. So it's kind of, think of it as like you're distributing your subtraction sign. So what we have here is x squared plus 3. And then your net minus times a positive x is a minus x. And a minus times a minus is positive, so you end up adding 1. Because again, the opposite of subtracting is adding, so that it's kind of like canceling each other out. But now we're just combining. So again, I can combine my 3 and now my plus 1. So I get x squared plus x, and 3 plus 1 is 4. Okay, looking at C. F g of x, that's the same as f of x times g of x. So again, my f of x is x squared plus 3. And I'm making sure it's in parentheses. And I'm multiplying that by my g of x, which is x minus 1. And now I have to distribute. So I get x squared times x is x cubed. X squared times negative 1 is minus 1x squared. You do not have to put the minus 1 there, remember. You do need the minus, you don't need the 1. 3 times x is 3x. And 3 times negative 1 is minus 3. None of these can combine. I have a cubed, a squared, an x, and then a constant. So that is our final answer. Then part D, right, f over g of x is the same as f of x over g of x. Well, our f of x is x squared plus 3. And our g of x is x minus 1. That looks like a B. Let me fix my 3 here. That looks like a better 3. X squared plus 3, x minus 1. There's nothing I can do to simplify these either. Sometimes there is, if you can like factor them and there's common factors. These ones don't. But the one thing we want to make sure of is remember, that denominator x minus 1 cannot equal 0. Remember, we cannot divide by 0. Okay, so we get x squared plus 3 over x minus 1, where x minus 1 does not equal 0. You can then go and solve that. Oh, I know x can't equal 1. That restricts my domain. All of those types of things. Okay, let's look at example 4. Let f of x equal x plus 4 and g of x equal the square root of 2x minus 3. So f plus g of x, again, f plus g of x is f of x plus g of x. And we have our f of x here. There. So f of x is x plus 4. And our g of x, oops, sorry, I'm adding these, is square root of 2x minus 3. Now, I cannot add things that are not in a square root and in a square root. Okay? We can't really add with square roots. So our final answer, I would just write it without the parentheses. So I have x plus 4 plus square root of 2x minus 3. You can't actually combine those anymore. All right, let's look at b then. It's going to kind of be the same idea, where I have f of x times g of x, where our f of x is x plus 4, and our g of x is square root of I am going to distribute by this plus sign. Okay, so I have x times the square root of 2x minus 3, and I have 4 times the square root of 2x minus 3. Okay, I can't distribute it into the square root, but I can distribute the square root to both of those. Okay. And that's it for algebraically combining functions. Our next piece, and our last piece that we're going to look at, is composition of functions. So what is composition of functions? Well, composition of functions is when we have something that looks like this. This is a nice open circle between the two, right? So the difference between this is like if I wrote just a dot would be like multiplication. Okay, this open circle is composition. So it's a very specific symbol. And this is set f of g of x. So f open circle g of x is the same as f of g of x. So do you see, we plugged g of x into f. You could also do it backwards. You could say g of f of x just means g of f of x. I'm going to plug f of x into g. So let's look at an example. We're going to let f of x equal x squared plus 3. And we're going to let g of x equal x minus 1. So we're going to find f of g of x. Again, this is the same thing as saying Right? So this blue piece is replacing all my x's. So I can think of it here as, right, oh, there's an x here. So I have, instead of x, I'm going to put what g of x is. Okay, so this is kind of like what we did with our function notation. It's just a slightly different notation where instead of saying, oh, it's f of x minus 1, we just say f of g of x, then g of x happens to be x minus 1. Okay. So then this is the same as, let me move this over. I'm gonna run out of room. Okay. So this is the same as, right, x minus 1 squared is the same as x minus 1 times x minus 1 plus 3. I'm going to distribute. X times x is x squared. X times negative 1 is negative 1x. I have to distribute here too. Negative 1 times x is negative 1x. And negative 1 times negative 1 is positive 1. Plus 3. Right, that plus 3 just kind of comes down. Then I'm just combining. So I have x squared minus 1x, those combine to minus 2x. And 1 plus 3 is plus 4. So f of g of x is x squared minus 2x plus 4. Okay, part B, we're going to do g of f of x. So if you notice, right, we flip-flopped. So this is g of, and now I'm going to put in f of x. So now I'm just doing the opposite. I'm putting f of x into g. So I'm going to place my x's, I do it like this, with f of x's. And that f of x is that x squared plus 3. Well, this is nice and easy. There's no multiplication. X squared plus 3 minus 1. I just can combine the 3 and the minus 1. You get x squared plus 2. So this is a good example of how your order really matters, right? And your order matters because, right, when I did it this way and when I did it this way, I got two very different answers. Okay, so you can't like flip-flop them and still be okay. All right, let's look at part C. F of g of negative 5. Well, that just means I'm going to take f of g, which is this function, and replace it with negative 5. Again, this is my f of g function over here. So I get negative 5 squared minus 2 times negative 5 plus 4. Negative 5 squared is 25. Negative 2 minus 5 is plus 10. And then plus 4. And 25 plus 10 plus 4 is 39. So you can still like plug things in, a number in, just like we did at the beginning when you have this new function. All right, let's look at another example. So example 6, we are going to let f of x equal the square root of 3 minus x. And we're going to let g of x equal 2x squared plus 8. So we're going to find f of g of x. So that's the same thing as f of g. Let's make it. My g is blue. Right? So I'm going to take my f function, which is the square root of 3 minus, and anywhere there's an x, I'm replacing it with the g of x. So that's going to equal, we have the square root of 3 minus, and my g of x is that 2x squared plus 8. So then I'm just going to distribute that negative, so I have 3, well, a negative times a positive is minus 2x squared. A negative times a positive is minus 8. I'm going to put it in nice, the nice order. I always put my x's first, so that's negative 2x squared. And then 3 minus 8 is negative 5. So f of g of x equals the square root of negative 2x squared minus 5. All right, let's look at g of f of x the opposite way now. So g of f of x so I take my function g, and anywhere there's an x, I put my f of x function. So here's an x, so I'm going to put in the square root of, or sorry, I'm going to put in f of x. We'll go through the pieces, and then add 8. So this is 2, and my f of x is the square root of 3 minus x. Oh, I'm sorry, I forgot this squared. Plus 8. So now just solving this, we have, well, the square root of 3 minus x squared. Remember, the square root and a squared are opposites. So this squared and this square root cancel each other out. So I'm just left with the 3 minus x. When I distribute 2 times 3 is 6. 2 times negative x is negative 2x. And I get negative 2x, and then 6 plus 8 is 14. Alright, the last thing we're going to look at is g of f of 7. Well, again, I'm going to take my g of f function, which we just found here, and I'm going to put in 7 for it. So I have negative 2 times 7 plus 14. Well, negative 2 times 7 is negative 14 plus 14. And negative 14 plus 14 is 0. Okay, one last thing we're going to look at with composition of the functions is actually going the opposite way. So it's called decomposing functions. I'm missing a page. Okay, so we're going to look at this example 7. And it says for each function h, find functions f and g such that h of x equals f of g of x. Okay, so you're just kind of breaking it down. Okay, so when I look at this h of x equals x plus 1 squared minus 3 times x plus 1 plus 4, I'm going to look for a function that's inside of it. Well, if I see here, I see this x plus 1 a few times. So, right, what I'm really looking for is f of g of x that equals this x plus 1 squared So I want to find this like g of x that's inside some like parentheses or inside this function. So I can see this like x plus 1 that pops up multiple times. So I'm going to say g of x is x plus 1. So now when I say, okay, I have my f of g of x, what I really have here is g of x squared minus 3 times g of x, bless me, plus 4. Okay. But what I really want to find is what f of x is. So basically all I'm going to do is I'm going to replace all my g of x's with an x. So really what I have here is instead of g of x squared, I just have x squared minus 3 instead of g of x, I just have x plus 4. So that gives me a g of x and an f of x that when I compose them as f of g of x will give me this h of x. Let's look at one more example like this. We have h of x equals x cubed plus 1. Ignore the bell. So again, I want to find my f of g of x that equals this x cubed plus 1. Okay. So you just need to find a function within this function. Well, I can say that this g of x is this x cubed plus 1. Right? There's that. Right? With no square root, right? It's just that piece inside. So then f of g of x equals the square root of g of x so then f of, when I want to find out what f of x is, it equals the square root of, well, I'm just going to put an x there. So I get g of x equals x cubed plus 1, and f of x equals the square root of x. Okay. One thing I want to point out, though, is that this might not be the only answer. Let's look at this problem a slightly different way. All right, I'm going to start with the same thing. I have f of g of x equals the square root of x cubed plus 1. So I want to find this g of x inside here. Well, I could say, oh, I think g of x is just this x cubed part. So if I say g of x equals just x cubed. So now when I find f of that g of x, equals the square root of, I'm going to just replace that x cubed with g of x, and I still have the plus 1. So when I find f of x and replace all my g of x's with an x, I have the square root of, well, yeah, g of x gets replaced with that x, and I still have that plus 1. So both of these would be perfectly good answers. So really what this says is there is multiple ways to decompose a function. Okay, so an answer isn't the only answer, okay? So we could have multiple ways of doing that type of problem. Okay, I guess. Okay, that is it. Have a good rest of your day.